All right, let's start. So if you read the instructions, it told you to keep x on the first position of y equal to. And then on the second one, replace them by whatever number you're doing. All right? So that, and you have y equals x graph on all those graphs. We just need to see how it compares the first one to the second one that we're going to put in y2. Okay? So the one for y2 would be x plus 2. And then when I graph it, what happens to the graph? What happens to the graph? Yeah, I know it's 2 lines, but what happens to the original? How is it change? All right. That's the first one, correct? All right. That's the first one. That's y equals x. That's your parent function. A parent function is a function that always goes through the origin because it has a y-intercept of 0. Thank you. You just don't need to say plus 0. Okay? So when I go to y equal to, and I put the second one in, x plus 2, and I graph it, how did I change my parent function? By adding 2, what happened to the graph? It shifted. It shifted up. And how many units do you think it shifted up? 2. Very good. So when I sketch, it doesn't have to be, oh, that was definitely not perfect. It doesn't have to be perfect, but it needs to be higher, right? And this one shifts up 2. That one goes up 2. All right, let's go to number 2. So for number 2, instead of x plus 2, I have 2x. So what happens to the parent function when I change it to 2x? Yeah, okay, but that, what changes? I'm not looking for what's the same, my babies. I'm looking for what changes. So what does that, say that again, Christian? So its steepness change. How did it change? How did it change? Okay, don't talk to me about higher or bottom because that's not correct. Christian used the correct word. He talked about the steepness of that line. It increased what? It does increase faster. How do you know that it increases faster? Because the line is steeper. So the line is not flatter. The line is what? Steeper. And why is it steeper? Why is the line steeper? Why is the line steeper? Those are your two functions. Why is the line steeper? Okay, what does that mean? Stop talking. All right, we can do this. Come on. Why is it steeper? What tells you when a line is steeper or flatter? What part of the equation tells you if a line, we don't know what slope is. You guys do not know what slope is because if you would know what slope is, you would know that the slope is the steepness of the line. The slope is how inclined that line is, which is the same thing as how steep it is. All right, you should have learned that in 7th grade, correct? Because they talk about all of that. And I know because I was in the 7th grade classroom last year, and I know what they taught. So why is the second line steeper? Thank you, because the slope is bigger. Very good. What is the slope on the first one? What about the second one? 2x. It doubled. Very good. So that's why that line is steeper. So let's sketch it. Yes, sir? We don't have tutorials today. We have tutorials on Friday. All right. What about the next one? What do you think is going to happen? It's going to go what? It's going to go down how many units? 6. Very good. Let's try just to make sure. X minus 6, and let's graph both of them. That's the first one. That's the second one. Is a lot lower. Very good. So this one goes all the way over there. So this one goes down 6 units. What about 1/2 x? What do you think is going to happen to 1/2 x? So it's going to be steeper? Okay, I got to teach, baby. You need to watch everything for this week. I told you that yesterday, Miguel. All right. So what happened to that other line? So it's not as steep, so this one became actually flatter, right? This one is a little flatter. All right. What do you think is going to happen to number 5? That one is going to be a lot steeper, very, very quick. It's going to grow very, very fast. And then what about number 6? It's going to go up 4 units. Very good. So this one is steeper. And this one goes up 4 units. All right. Without using your calculator, let's go ahead and estimate the change. 1/4 x. 1/4 x? Flatter. Thank you, Cornelius. Flatter. So it needs to be under that one. What about x minus 3? It shifts down 3 units. Very good. So it's the same slope, it just goes down 3 units. All right. So let's summarize the changes. When you change A, and this is what A is, what is A? What is A? The slope. A is the slope. When you change A, what happens? What changes? The slope. Which means it's either going to be what? Steeper or flatter. So when you change to B, what changes? The y-intercept. Which means it's either going to go where? Up or down. Stop playing. All right, so what happens when the slope, or A, is bigger than 1? And take a look at your top graphs to make sure to make a prediction. If it's bigger than 1, if A is bigger than 1, what happens to the line? Yeah, it's bigger than 1, so the hope is higher. Because your parent function is just slope of 1. Your parent function is y equals x. So what happens when it's bigger than 1? Look at this and make a generalization. Start thinking. Look at your graphs and look at when A is bigger than 1 and tell me what happens to the line. What happens to the line? It's right there. What you guys can't... What do you mean you can't see? You have it on your paper if you copy what I copy. Isn't that bigger than 1? Isn't that bigger than 1? Okay, can we start thinking and making generalizations? Because it's right there. I wrote it for you. It's steeper. We can do this. What about when A is less than 1? Thank you. 1/4 is 1/2 is less than 1. 1/4 is less than 1, and both of them have the word what attached to it. Flatter. All right. With the y-intercept, adding means you are shifting where? Very good. It goes up. And subtracting means you are shifting down. There you go. Yay? All right. Put that in your notebook. We'll do the back tomorrow because we're not going to have time to do it today. I didn't have time with the other group. All right. Take your paper, the one that has lines. The copies are a little crooked. I'm sorry. So just go ahead and try to fold it as best as you can to the middle so that it looks like this. All right. But the copies were, when I did the paper, it wasn't crooked, but when I made the copies, it was. So, and then you need to cut it through here. Cut it through the lines. All right. So that it kind of looks like this. Okay? Take the ruler. Take a ruler inside your box and make a line through the middle section. Try to do it in the middle. It really doesn't matter. Just, estimate. It's all good. All right, so make sure you're writing those. If you don't have what you can't see, don't worry about it. I'll move it up once we start writing. Okay? So if you don't have it, don't worry. Let's go ahead and start. All right, so the parent function is x. F of x is always going to be x. And when it's x, it goes up. So when it's negative x, what do you think is going to happen? It's going to go down because the slope completely changes, right? All right, so for f, for the opposite of f of x, the graph of the function reflects across the x-axis. And all that means is that instead of going up, it's going to go down. So that was for this side. All right. So there's a difference between having the negative over here and having the negative inside. For this one, it doesn't reflect around across the x-axis. It reflects around across the y-axis. All right, ready for the next two? When you added C, what happened to that one? It shifts up, right? So the graph of the function is shifted C units up. It depends on what C is. If C is 3, it's up 3. But if C is 10, it's up 10, right? So the graph of the function if shifted C units up. But when it's subtraction, it doesn't move up, it moves where? Down. So the graph of the function is shifted C units down. So these are the four that you need to learn for linear functions. We are going to finish the foldable, but the last four are more for quadratics when we do those, okay? So let's go ahead and start with the first one. So we're going to copy them, but you don't need to worry about the last four right now. You will use them when we do quadratics. So for this one, it moves to the left, and for that one, it moves to the right. Okay. So the graph of the function, they all start the same way. Well, except for that last one. I'm sorry. It shifted C units to the left. And then on the other side, it shifted to the right. Okay, so it's always the opposite. If you haven't figured out that by now. Okay? So these are the next two if you didn't copy them. What time do you guys leave? 12:15. Okay. We gotta finish this. Alright, for this one, if C is bigger than 1, and this is more for quadratics, C is bigger than 1, so that means 2, 3, 4, 5, 6. 1.1 is bigger than 1. It vertically stretches the graph. And you learn what that is in quadratics, so you don't need to worry about that right now. But if the C is between greater than 0 but less than 1, it vertically compresses the graph. Alright, this one does the same, but it doesn't do it vertically, it does it horizontally. Very good, you got it. But it also changes. Instead of stretching, it's going to horizontally compress the graph. Alright, once you're done, you take your pink paper and glue the middle Make sure that you have it like you're putting it on the notebook, right? So the holes need to go to the left. And then we just glue it right there.